Have you seen the doll as shown in the above picture? It is a nesting doll. It is a set of dolls of decreasing size kept inside one another. So, we have a doll inside a doll, another doll inside that doll, and another doll inside that doll. Recursion aligns with the same concept. Let's see how. We are familiar with calling a function. Remember? We write the name of the function followed by parameters in parentheses terminated by a semicolon. Normally, we call a function from another function. Recursion is when we repeatedly make a call to a function from inside the same function. But, the similar thing can be achieved using loops, don't you think? But recursive functions are easy to write and read, and hence easy to maintain. And implementing the same thing using loops might require writing a relatively complex logic. The above snippet describes the idea of recursion. We call this function inside the function itself. But once this function is called, it will go into an infinite loop. The function calls itself repeatedly and there is no stopping point. So, how does this stop? This recursive calling stops when the exit condition is met. While calling a function recursively, it is necessary to write an exit condition or else the program will fall into an infinite loop. Let's understand this from a simple program with recursive calls. Here we do have an exit condition. If the value of I becomes equal to 1, then the execution comes out the recursive call function. The output of the above program will be Recursion can also be used to find the factorial of a number. Factorial of a number is the product of the number and all the positive integers less than the number. So, the factorial of 5, which is denoted as 5, will be 5 times 4 times 3 times 2 times 1, which comes out to be 120. Let's write a recursive function to find the factorial of a number. Let's analyze the above recursive function. Suppose the number 3 is passed to the function factorial when it is called. Now firstly, the function checks if the value passed is less than or equal to 1. If it is less than or equal to 1, it returns 1 and the execution stops. If the condition is found to be false, the execution comes to return I factorial I, 1, here, I equals 3. Thus this breaks down to 3 factorial 2. From here factorial function is called again now with I equals 2. Which will eventually come down to 2 factorial 1. And, now since the value of I equals 1, the first condition will be satisfied and the function will return 1 this time. So, 2 factorial 1 will become 2 times 1 equals 2, which is nothing but the result of factorial 2. Then, 3 factorial 2 will become 3 times 2, which is 6. Using our generic way, 3 equals 3 times 2 times 1 equals 6. Thus our implementation is correct. Recursion is when we repeatedly make a call to a function from inside the same function. Recursive functions are easy to write, read and maintain. It is necessary to write an exit condition or else the program will fall into an infinite loop.